want to do first? Let's go numerically. So let's go 23. 23 first, okay? Let me find it. 23. 23. Ah, it's word problem. Okay. Oh, we did this in the other class. Okay, it says to estimate the height of a tree, Dave stands in the shadow of the tree so that his shadow and the tree's shadow end at the same point. Hear what I just said? So let's draw a little picture that talks about this. Look, I would draw a picture. There's no way I'm going to try this without visualizing it, okay, and seeing this written down. So let's say that's the ground. Let's say that's the tree. Whoops, I didn't hit the ground, did I? Sorry, scooch it over. There I am. Now I'm back on Earth. Okay, so let's say that's the tree right there. And what's it say? He does what? He stands in the shadow of the tree so that his shadow ends at the same point, right, as what the tree does? You follow me on that? Okay, so he's shorter than the tree, I would think. So right there. So I may have to make some adjustments here, but let's do this. Let's say here, this line right here that I'm drawing is basically the sun's rays, right? And so it casts a shadow. See, this tree is casting a shadow. So this line along the ground right here is the shadow itself. And it says both of their shadows ends at the same point. See, here's Dave right here. You see him? You recognize Dave? Doesn't he look good? And so his shadow ends right here, and the shadow of the tree ends at the same point. All right, so he's walking back and forth just to make sure his shadow ends at the same place. So instead of climbing up the tree and throwing down a measuring tape or something like that, it'd be kind of hard to measure how high the tree is. He can measure some other stuff. He could probably very easily measure how long that shadow is and how long his shadow is, and he knows his height. Okay, so it wouldn't be that difficult for an approximation anyway to find out how tall that tree is. See, that's how we can use geometry to find something that would be a little bit more difficult to find. Isn't that a good idea? Did you ever think of doing that? If you wanted to find out how tall something was, you could find out how tall a building was by looking at the shadow that it casts and all that kind of stuff if you know the distances. Okay, it'd be kind of interesting, wouldn't it? All right, so let's put some numbers in there. It says Dave is 6 feet 4 inches. Now this is important that you watch this. Yeah, he's kind of tall, 6'4". All right. Now in Korea, you would never say 6'4". You go by centimeters, right? You say I'm so many centimeters, right? But we don't do that. We should, but we don't. So he's 6'4". So how many centimeters are you, David? How tall? Yep. 170. Okay. So he's a little less than 2 meters, right? 2 meters is kind of close to 2 yards, right? 2 yards would be what? 6 feet. So he's a little bit, so he's probably what, 5'8", something like that would be my guess. You could always figure it out. But anyway, 6'4". We're going by feet and inches though on this one. On the quiz there was one. I'm not going to give it away, but some people do this. Some people say it's 6.4 feet. Is that the same thing? No. 6.4 is not the same as 6 feet 4 inches. Okay, to figure out what the decimal is, and if we want to use a decimal, we can, or we can use a fraction. If we're going to write everything in terms of feet, what would we do? Go ahead. It'd be, no, that's fine. It's 4 inches divided by what? 4 out of 12, right? That's how many feet it is. Well, what's 4 over 12? It's 1/3. Now, I'm not going to write 0.3 because 0.3 is not exact, all right? But 1/3 is, right? Because it's 0.333 and it keeps repeating. So I'm going to keep it 1/3. So I'm going to say he's 6 1/3 feet. To make it a little easier for my math, I'm not going to write it in mixed number. I'm going to write it improper. What would that be as an improper? 19 over 3. So you wouldn't normally go to somebody and say, well, I'm 19 over 3 feet. That doesn't make any sense, okay? But that's technically what he is. Would you agree with that? All right, so it just makes it easier on our math when we're doing this stuff. So this height right here is 19/3. So we'll put 19 over 3. It's supposed to be a 9 right there. All right, that's his height. What else do they tell you on this? They tell you his shadow is 15 feet long. Well, where's his shadow? It's from here to there, and that's 15. And what else does it say? Thank you. It says he's standing 66 feet away from the tree. So that doesn't mean the whole shadow of the tree is 66, does it? It means he's standing right here. That's where he's standing. Here's the tree. So that distance right there is 66. Gotta go right now in the middle of this. All right, you see what we're doing? And what are we trying? We're trying to find out how tall the tree is. We'll call it h for height. Is that all right?
Yes.
Okay. So what do we have? We actually have two similar triangles, don't we? Look at this little tiny triangle. It's got this angle, and he's standing straight up and down, so we're kind of making a little bit of an assumption on this, that that's a right angle, and we're assuming the tree is straight up and down according to the ground. And but I think that's a safe assumption to make. And so we have a right angle here and here. Look at the big triangle. What does it have? It's got a right angle, and it shares this little angle down here too, doesn't it? So it's got those two angles. Look at the little triangle. It's got a right angle, and it shares the same exact angle. So those two triangles are what? They're similar to each other. So they are similar triangles, so we can set up a proportion. Let's figure out what our proportion is. We're going to compare the height of the tree to the height of Dave. So h over 19 over 3. Right? That's our ratio for the height of the tree and the height of Dave. Now, what are we going to compare it to? This is the one side of the big triangle, and this is the up and down side of the little triangle. So what I have to do is I got to put the big length here, and I got to put the little length here. Do I put 66 here? 66 plus 15. That's right. Okay, because the whole entire length, you got to take that whole length, not just the 66. The whole entire length. What's 66 and 15? That's 7. That's 81. Okay, so that's the whole length. Everybody see that? You got to take that whole length and compare it to the bottom of the little triangle. What's the bottom of the little triangle? It's 15. That's your ratio right there. And now you can cross multiply and solve for it. You could do this a couple different ways. You could cross multiply. It might be easier since h is already on top. How do I get rid of that 19 over 3? Okay, I could, well, I'm actually going to multiply it by, since I'm dividing by 19/3, I want to multiply it by 19/3. Do you see that? So what am I going to do over here? Multiply this by what? 19 over 3. All right. You could use a calculator if you want at this point, or you can simplify a few things, I guess. Let's see. 3 goes into 81, right? What's that? 27 times. Okay, and then 3 goes into both of these. 3 goes into that what? 5 times and 9 times. So whatever 19, let's see, 20 times 9 is 180. So that's what, 171? Is that right? 171 over 5. What's that come out to? Taylor, you got a calculator? 171 over 5?
34.2.
All right, good. And that's the answer. How about that? It's 34.2 what? This is in feet, because we changed this from inches to feet, didn't we? All right, I want to stay in one unit. I don't want to have a combination of feet and inches. That's why I changed that just to feet. And there it is, right there. Or you could have changed it to inches if you wanted to, but I think number's a little bit smaller if you keep it in feet. What about that? Well, it's 2/10 of a foot. So let's see. I would do this. Watch, it's 0.2 feet, right? I'm going to do a little bit of this. Put feet down here, put inches down here. So I just multiply it by 12, and that would be what? 2.4, right? Is that right? Yeah, but then I got to do the 0.4. That's good enough. Just write 34.2 feet. It's good enough. Okay? Because it doesn't come out exactly to the fractions we recognize. So we'll just keep it like that. All right, so that was what, number 23. That was probably the hardest out of all of these, I think. 28, the next one. Let's take a look at that. Like that one right there? Yeah, sure. I could put one like that. Yeah. You can.
Is test tomorrow?
Yes, test is tomorrow. All right, we've got basically how they set this up in the book. So we have one triangle, and that one angle is being bisected. And they tell you some lengths. They tell you that's 9. They tell you that's 10. This is W. And they tell you this whole thing right there is 36. Well, do you remember the little whatchamacallit? Is that blue going to be too dark? Well, that can. You can read that, right? Looks nice. Okay. Do you remember the little theorem that says this? If we have a triangle and you bisect one of the angles, look what it does. It splits this opposite side into two segments. Do you see it? This one segment is W. This segment's not really named, but it splits this segment into two segments that are proportional to the other two sides of the triangle. All right. So what do I need to do? Well, I know that's W. It'd be nice if I knew that little segment right there. If I knew that little segment right there, I'm practically done. Okay, I gotta just apply my theorem, then I'm good to go. All right. So the other class had a little bit of trouble thinking of what this is. But what if this was a number? What if it was like, I don't know, 20? Right? How would you figure out what this is? You wouldn't even think about it, would you?
It's 36
You go 36 minus 20, right? But this would be 36 minus W. No, can you read that? That's a little dark, isn't it? What does it look like up there? Oh, yeah, that's hard to read. Let's change colors. Let's go a little bit bluer. Okay, so this is 36 minus W. Now, for some people, that's hard to see. Some just can't visualize that. But if I stuck a number in here, if I said this was 20, most people could see this and say, oh yeah, it's 36 minus 20, which is 16. That would be 16. Like, well, okay, think of it as the same exact way. But it's not 20. It could be any kind of number. So 36 minus W is this length right here. So now, to me, that was like the hardest part of figuring out this problem. Now the rest is kind of easy, actually. What do? We can compare this one to this one, and then this one to this one. All right? So watch, W to 10. Because remember, these segments are proportional to the other two sides, right? These segments. So W to 10, what do you think the other one is? 36 minus W to what? To 9. All right? And now I can do a little cross multiply and then solve for W. All right? So 3W equals, what's that? 360 minus what? 10W, right? Add a 10W, that's 19W equals 360 divided by 19. Taylor, what's that? 360 divided by 19. Oh, it does come out as a decimal. Okay. I thought it came out exactly even, but I guess it doesn't. 18.9 something?
Yeah,
okay.
18.94736.
All right. All right, and we'll just keep it like that. And that's fine. They said 19. They rounded, obviously, but we'll just keep it 18.9. We good with that? All right. And the other one was what? 23 or something like that? No, we already did 23. 33, I think it was. Yeah, 33. All right, so let's see what we can do here. Let's go. Have we gone green? You want to go real light green?
Maybe yellow.
Didn't we do yellow already? All right, let's take a look at 33. Okay, now they didn't ask about this one, so this will be my first time seeing it. In a scale drawing of school's floor plan, 6 inches represents 100 feet. So let's write that down. So 6 inches, we'll say equals 100 feet. That doesn't make much sense because 6 inches is absolutely not the same length as 100 feet, is it? But you get my idea. Okay, every 6 inches you go on the map, it's 100 feet in real life. All right. If the distance from one end of the main hallway to the other is 175, find the corresponding length in the scale drawing. So from here to here, it's 175 feet in real life, right? What would the length on the picture be? You follow me? So let's make a scale factor. Let's go what? 6 to 100. So the 6 represents the map, right? MAP. And the 100 represents what? We'll call it real life. Is that all right? Okay. Full scale. All right, so the map to real life. So what are we going to put over here? What are we trying to find? We're trying to find out how many inches on the map, right? So we'll call that X. What is it in real life? 175. And then you're good to go. This should work. So multiply both sides by 175. Multiply this side by 175. And do the math. And let's see. Taylor, you're the calculator lady. Is it 10.5? What she said. Good. There you go. And that's it. That's the answer they give you right there. Does that make sense? Just, again, scale factor, proportions, this whole thing, this whole chapter has been about ratios and proportions and scale factor and all that good stuff. All right, so make sure you think about doing that. What do you think? Is that all right?
Yeah.
I think it should be fine for this test. It shouldn't be that hard. Okay. All right. Well, if that's it, then that's it. I'm gonna let you hang on to that until tomorrow. Make sure you bring it with you tomorrow. Don't leave it in your locker. You don't have to bring your book to class tomorrow for the test, but bring your homework. All right, so you can turn it in tomorrow. Okay. Remember, test tomorrow, chapter 7.